Everyone, I'm Bao Qixun from National Time Service Center, Chinese Academic of Sciences. And my topic covers 5 parts. After the motivation introduction, I will give some results about software and strategy comparison, then give some details about time transfer based on original BDS and GALILEO system with initial service. In the end is a summary and outlook. As we know, TI computation is based on time transfer between time labs around the world. And as early as 1981, GPS has been introduced for international time transfer in the Commonwealth mode. And GPS PPP has been integrated in routine in TI computation since 2009. The next year, GLONASS has been also involved in TI computation. From the table, we can see that there are totally 72 time links used in TI computation from Security January 2007. Of these links, there are 70 links are related with GPS, and 28 links are used GPS PPP technique. So PPP technique plays an important role in TI computation. In theory, we know the multi-GNS constellation could improve the precision, accuracy, and reliability of TI computation. The Chinese BDS system has provided service since December 2012. Although currently it is only has a regional constellation, the BDS satellites could also be observed outside the Asian and Pacific area. And the GALILEO system has come into the initial service since December 15 last year. So the purpose of our work is to investigate how its performance of PPPTI time transfer based on regional BDS and the GALILEO system with initial service. So first, we give some comparison of about our software and strategy and the BRPM TI PPP. The BRPM TI PPP has been integrated standard data analysis for TI computation, and it is based on the Arcan PPP software. The processing arc length is 35 days, and they use RGS rapid orbit and clock products. In our work, we used a modified Bernice 5.2 software, and with 1 day arc. Of course, to process multi-GNS data, we have to use the multi-GNS products. First, we use the same data and products as BRPM, and to see the consistency of our daily GPS PPP results and with the results of monthly BRPM TI PPP. 6 stations from the RGS network was used. All these stations are hosted by Time Lab and have participated in TI computation. The data span is from January 2015 to May 2017. The right graphic gives results of our daily GPS PPP compared with BRPM monthly PPP. We can see from that, for most stations, the deviation is about 0.1 nanoseconds. But for the newest station, it has the worst result. We look at the time series of newest station and see that there are some large daily boundary discontinuities in the time series, so we think this is the reason. And then we use the same data, but changed to multi-GNS products, and to see how its performance based on multi-GNS products. In the top graphics are the time series compared with BRPM TI PPP on link, BRUX, and PTBB. We can see from that, although it is a little bit noisy in the first several months of 2015, the overall result is around 0.1 nanoseconds, both with GBM and COM products. The graphics in the bottom are the results for all the time link. This slide shows that the GPS PPP based on our BDS software in daily model could get a good performance as long as the data quality is normal. For the results of BDS PPP, we used 10 MJAX stations. All these stations have at least GPS and BDS observation, and also have high-performance external clocks. 2 of the stations are located in time lab. The data span is from January 2015 to December 2016. And 7 of the stations are located in Europe, and the other 3 are in Asian and Oceania. For the BDS availability and data quality at BRUX on DOY 33/2027, we can see that at least 3 Beidou satellites could be seen simultaneously the whole day. But for the elevation angle for most satellites at most time, they are below 40 degrees. The code multipass on the B1 signal is about 50 centimeters. Four solutions are designed and carried out according to different strategies. For the estimated parameters, we have options whether estimate coordinate and troposphere delay together with receiver clocks. If we do not estimate them, we introduce the values from GPS solutions and fix them. And for the products, we have the GBM products with Beidou GEO satellites included, and the time interval in the clock product is 30 seconds. And the other one is COM products, which have no GEO satellites, and the interval is 300 seconds in clock product. And the GPS PPP results with GBM products as a reference to evaluate the BDS PPP. Okay. So this slide shows results of BDS PPP. We can see that since May 2015, with the improve of the products, the PPP results with BDS only has been on the same level with the other 2 strategies, and all the 3 strategies are below 1 nanoseconds. This slide shows the results of code fixed and the troposphere fixed BDS PPP result. The top one is based on GBM products, and the bottom one is C1 products. With GBM products, we can get a result better than 0.5 nanoseconds. Okay, let's move on to the results of Galileo. 8 stations selected, and the data span is from 15 December 2016 to May 1st this year. This is the Galileo visibility and data quality at BIUX, and we can see that the Galileo has better geometry at Europe stations. 7 solutions were designed and carried out according to different strategies. The option including the estimated parameters, the selected observations, and the products used. So this is the result of GALILEO PPP. We can see that from the left graphic, it is the overall results for all the solutions and all the time links. We can see that the overall result is less than 0.5 nanoseconds. And the left graphic shows the troposphere fixed solution has the best results compared with the GPS PPP. So a summary, a short summary, and the differences of daily BDS PPP are less than 0.6 nanosecond with GBM products and less than 0.8 nanosecond with COM products. For Galileo in initial service, the best solution of daily PPP could be less than 0.4 nanoseconds for the tested links. For the future, in my opinion, I think it is necessary to launch a campaign for multi-GNS time transfer. Thank you very much.